Hello children, today I have a very interesting and important problem of the chapter similar triangles. As you must be having your examinations, your pre-board examinations in the schools, right? So you should try to focus on this problem, and this problem is going to give you an overview of what this chapter is all about, right? So let us start without further ado. So see children, in this question what is given? OB is the perpendicular bisector of the line segment DE. So OB, you can see this is OB is the perpendicular bisector of this line segment DE, right? And then what else is given? FA is perpendicular to OB. Before that, since OB is perpendicular as well as its bisector, so what will we do here? We will mark BD equal to BE, right? Because B is the midpoint of DE. And FA is perpendicular to OB. FA is perpendicular to OB. And FE intersects OB at the point C. And you can see that FE intersects, if this is FE, intersects OB at point C. We have to prove this relationship. Now, the most important feature of taking this question up and doing it is that children to make you aware of how we can prove these, how we can solve these questions, जहाँ पे हमें where we have to get an expression which is required from us. Yeah, so the important thing here to notice is that how you can start and continue with the flow, and you always when you are doing that you have to keep an eye on the expression which you are about to show. So the moment you take your eyes away, जैसे ही हम क्वेश्चन से दूर हो जाएंगे, you will not be able to solve this, right? So let us try to solve it. So you know that children, what is given to you? FA is perpendicular to OB and DB is perpendicular to OB as well, right? Because it is written that OB is perpendicular bisector and FA is perpendicular to OB. So in triangle OFA and triangle ODB. See these two triangles. So in these two triangles, by the means of similarity, I can say that angle A of OFA is equals to this angle A of OFA is equals to, you can see this angle B of OBD, right? So angle B of OBD, both 90 degrees each, followed by angle O is common between both the triangles. So angle O is equals to angle O. This is a common angle. So by double A congruency, triangle OFA is similar to triangle ODB. We can see the order as well, like O corresponds to O, right? A corresponds to B. A is the third letter here, so B must be the third letter here. So the correspondences we can check here itself, and they are all right. Now by corresponding parts of similar triangles. Why did I in the beginning choose these two triangles and try to and have obtained them similar successfully? इनको क्यों मैं लेके आया, क्यों choose किया, अभी you will get to know. See, I wanted the ratio, I wanted OA, OB to be in my picture right now. So that is how I can get the ratio OA and upon corresponding ratios of the sides, right, upon OB. Now on the other hand, I can write OF, that is OF upon OD, right? And let us highlight it. This is a very important expression and it will be made use of sometime later, because you know that OA and OB, they are in the expression, and I told you in the beginning, taking the eyes away from the question can harm us, right? So let us try to do it. See, continue doing it. So now, uh, one more thing I can do here, children, is that I can simply draw. a ray, let us say this is a ray BT parallel to FE. Why did I choose to draw this parallel? Because you know that from class 9, if there is a triangle ABC, if a line segment starts from the midpoint of one side of a triangle is parallel to the second side, then it must bisect the third side, right? So I have to show that this point of intersection of BT with OD, that is, let us say M. So I want to show that is M is the midpoint of FD, right? Which triangle am I talking about? See this triangle, children. See this one, this triangle. That is FDE, only FDE. So in FDE, what did we do? We drew BT parallel to FE, and M is the point of intersection of FD with BT. And by the converse of midpoint theorem in class 9, since this was the midpoint, B was the midpoint of DE, and BT is parallel to FE, therefore FM will be equal to DM. And this will have a very important role in our process of solving the problem. See how. So what now we can do is construction. I hope you remembered. So there is nothing to write. If you wish, you can write that construct BT construct BT parallel to EF such that such that it intersects FD, or you might write OD. OD का ही part है FD, right? So we can write one of the segments. So it intersects FD at M, and by converse of midpoint theorem, as already we have B the midpoint of DE, right? B is the midpoint of DE. So I can write that as B already is midpoint of DE. I can write that M is the midpoint. M is the midpoint of DF. Or I can say that MF is equals to MD, right? Again, a very important finding. We must save it for our further use. आगे के लिए इसको बचा के रखेंगे. Now see what else can be done. You have this again this triangle children. See, I should clear the figure off, right? See, so this goes off like this. Delete. Now try to understand. So this triangle I would like to see, but before that we mistakenly have deleted what we constructed. So this was BT if you remember, and this was parallel to FE and intersected OD at M. Now the triangle which I need to take is children OMB, this triangle. See, in this triangle you can see that you drew BT पैरेलल टू FE, राइट? हमने क्या बनाया था? BT को FE के पैरेलल बनाया था, तो BM will also be parallel to CF, right? See this triangle I'm talking about, this one. The name of the triangle is BM. This is F, this is C, and this is O. So this will be parallel to this segment, right? Now we can use children, either you can use your basic proportionality theorem or you can use similarity. Both will have the same consequences. So this was our BT running through intersecting FD at M parallel to CF. Now in triangle OBM, in triangle OBM, so and triangle, you can take the triangle OBM and you can take the triangle OCF, right? And triangle OCF. angle O is common, right? Angle O is common, and since CF is parallel to BT, therefore these two angles, angle C and this angle, you can name it as OBM, right? So you can say that angle C, OCF, angle OCF of triangle OCF is equals to angle OBM of triangle OBM, right? So by, therefore we can first we can draw the margin here. Therefore, by double A similarity, again we can say that triangle OFC या OCF, whatever you may choose, but the order should be right. अगर इधर लिया है OCF, then it should be OBM, right? Triangle OBM. Why? What is the reason? Because see the position of the second letter angle, that is C. C was standing equal to B, hence जहाँ पे C दिख रहा है वहाँ पे उस पोजीशन पे सेकंड पोजीशन पे B भी दिखना चाहिए. ठीक है, so that is what you need to remember. The order are very important. The order is very important, the most important concept in this chapter. Now what can next be done? Why, what help shall it bring to us? See again, by CPST. By CPST, I can write that I need to get OC, right? Also, so by CPST, I can write OC because यहीं से OC आएगा. OC तो यहाँ से क्या लेना पड़ेगा? OB लेना पड़ेगा. And then you can write OF upon OM. So OF upon OM because corresponding the ratio of the corresponding sides are equal, right? So let us mark this very important finding as 3. We might use it or we might improve it further. So now I want OC to exist in my expression. OC, I want children OC, OB and OA, right? Only these three quantities which are the most wanted ones. So let us finish it off quickly. So now as OC is upon OB is equal to OF upon OM. Now see this, what special is about OM. OM can be written as OF plus FM, right? OF plus FM. Further you can write that OF upon OF plus FM. I can write FM as half of FD if nobody has any problem, I believe, because we already declared from second equation that MF equal to MD, right? So I can say that this was T, as this was M and this was ray BT. So this M is the midpoint of FD, therefore MF is equals to DM or MD, and FM can be written as half of FD. अगर ऐसा नहीं समझ में आ रहा तो you can imagine here me writing like this because MF plus MD is equals to FD. Since both are equal, so I can write twice of MF equal to FD, and MF can be written as FD by 2, right? So we made the use of expression number 2. Now by further proceeding over it, I can by using some cross multiplication, sorry, by using LCM and sending 2 here, I can write that OF upon twice of OF plus FD, right? Now where this 2 will go, this 2 will jump in the numerator and will exist in the numerator, right? So now OC upon OB will be written as twice of OF upon twice of OF plus FD. See children, we only want OC, OB and we have OF and FD lying here. You can see OF and FD. But we do not want OF and FD. हमें चाहिए क्या? We want OA, right? And OF and FD, I can see here from expression number 1, OF upon OD is something given to us, OA upon OB. So I can get the same thing back here. How? Let us try to refine it further. See all of it. So I will write this as by flipping both the equations, both the sides of the equation. मैं लिख सकता हूँ OB upon OC equal to twice of OF plus FD upon twice of OF. By further proceeding on with the given equation, I can write twice of OF upon OF, right? Twice of OF upon OF, twice of OF plus FD FD upon twice of OF. Now you can see these two quantities are set to cancel each other out, right? So what I have here, children, is that OB upon OC equals to 1 plus FD upon twice of OF. So now we have, children, come to this point where OB upon OC is equals to 1 plus FD upon OF. 1 plus FD upon twice of OF. But we want OF, we want OD. But if I need to substitute, I need to bring OA upon OB को भी कैसे भी करके लेके आना है, तो I have to have OF upon OD some sort of that fraction, right? तो हमें लेके आना है यहाँ पे कैसे भी करके हमें we have to bring OF this form OF upon OD कैसे भी करके इसको हमें लेके आना है but that way should be right, it should not be illegitimate. So I can see that I can see that OB upon OC I can write it as like 1 plus instead of FD, children see the diagram carefully. Instead of FD, I can write, if you see it closely, FD is nothing but, see here, let me erase these lines. FD is actually OD में से अगर हम OF को subtract कर देंगे तो we will get FD, right? So I can write, instead of FD, I can write OF, right? OF, sorry, OD minus OF. So it will be OD. Let me zoom out. So it will be kind of like writing here again OB upon OC was brought equal to 1 plus FD. I told you it is OD minus OF upon twice of OF. So by taking the LCM and taking this denominator with 1, I will get twice of OF plus OD minus OF upon twice of OF. And further on solving, I can get twice of OF minus OF will be 1 OF. So OF plus OD upon twice of OF. So OB upon OC is equals to 1 by 2. I have split the denominator, right? So OF will cancel out with this OF plus OD upon twice of OF. So we are successful in getting this fraction, children. OD upon OF. So what will OD upon OF be? If I write here, OD upon OF will be equal to OB upon OA. इसी का reciprocal कर देंगे equation number 1 का, right? So I can further write like this. It will be equal to 1 by 2 plus 1 by 2 will remain constant here. OD upon OF की जगह पर OD upon OF की जगह पर I will write OB upon OA. So it will be OB upon OB. Now understand what can be done further. Now diagram has no importance. We already are with the expression now. So we are here OB upon OC equal to half plus OB upon twice of OA. Why not to take the LCM here? So LCM will be twice of OA, and the numerator will be OA and OB into 1, that is OB. Now see children, if you flip the equation, that is in place of OC, OB OC will come and in place of OC OB will come, flip कर दिया equation को तो ये flip हो जाएगा और ये भी flip हो जाएगा. So it will be kind of like twice of OA upon O. Sorry, flipping is not required here, right? Flipping is not required. We already can bring two on the top. To यहाँ पे लेके जा सकते हैं हम. हमें क्या चाहिए? We want. Let us review what we want, children. We wanted that 1 upon OA plus 1 upon OB equal to 1 twice of, right? So twice of 1 upon OC. We can check whether we wanted this or not. Yes, that is the correct expression we can see here. So flipping right now will not help. So I'm just writing these two expressions which are wanted here, right? So I'm again only writing these two expressions here. So OB upon OC equal to OA plus OB upon twice of OA. Now what do you need here? You need 2 with OC, right? This is what we want. I told you in the beginning, children, you have to keep always, you don't have to take your eyes away from what you wanted to, from what you want to show. जो हमें शो करना है उससे कभी हमें आंखें दूर नहीं करनी चाहिए और ना करनी है, अदरवाइज ये नहीं हो पाएगा. ठीक, तो इसको आगे कंटिन्यू करेंगे. तो OB की जगह पे हम 2 यहाँ से भेजते हैं. वी विल सेंड 2. तो 2 को भेजा इधर, नीचे उसी को ही छोड़ दिया और ऊपर यहाँ पे क्या लिखा हुआ है OA प्लस OB और डिनोमिनेटर में OB को हम इधर भेज देंगे. तो OA ऑलरेडी है यहाँ पे और क्या हो जाएगा OB. So now see twice of 1 upon OC will be equal to, I am splitting the denominator, right, into OB plus OB upon OA into OB. So finally we are done, children. This OA will cancel out OA and OB will cancel out OB, and then we can successfully write that twice of 1 upon OC is equals to 1 upon OB plus 1 upon OA. So this is what we wanted and we have successfully shown it. So this solution might seemingly be appearing to you longer, but I have written some minute steps. Like here I wrote some steps which you can already skip and you can make the solution much shorter, right? So there is no need to be afraid of this chapter similar triangles. It is very fun to do, and always sometimes you do need to struggle, and then if you run away from the struggle you will never succeed, right? So take care of this fact, and if you really like the solution, do like and subscribe to my channel, children, right? Then I will be back with certain more questions which are fun to solve, right? Thank you, children. Have a nice day.